Really big word. Ready? Indirect measure. INDIRECT. That's the word indirect. MEAU. Whoops. Miss Hoff can't spell. MEASURE. Measure. Indirect measure allows you to the properties of similar polygons to find distances or lengths that are difficult to measure. Everybody agree, we could not walk outside right now and just easily measure how tall that goalpost is outside. Okay? It's way too tall. You could not directly walk up and measure. It's too big. So we can use similar polygons in order to find measurements like that, or the height of a building, or the height of a telephone pole. The first thing we have to talk about is angle-angle similarity. If two angles of one triangle are equal, kind of the same thing, congruent, to two angles of another triangle, then the triangles are similar. Okay? You got to find me two angles in one that are the same degrees as two angles in the other. Okay? So let's look at our example one. Determine whether the triangles are similar. If so, write a similarity statement. Angle blank and angle blank have the same measure, so they are blank. What do I want to fill my blanks in there? Angle, Jack? A and E have the same measure, so they are, now here's your word, congruent. Okay, he saw that because they both say 62 right here. Good work. Now they say angle blank and angle blank measure 70 degrees. Angle C, but G doesn't have a number. I'd like to say it's G, but how can you prove to me it's G? Courtney? Okay. How do you know that, though? I know you want to do that. You know you want to, but you got to prove it to me. Liana? Okay, and we want to, but we're trying to decide if they're similar. So you have to prove it to me mathematically. I get what you guys are saying, like totally. Rotate that and it looks like G and C should match up and B and F should match up. But how could you prove to me that G is 70 degrees? Boom, Addison. All triangles add up to equal 180 degrees. So right here, if I take 62 plus 48, what do I get? 110. And if this triangle should equal 180, if I take 180 minus 110, I get, careful, just 70, right? That proves, you guys are absolutely right, that C and G are 70 degrees. Now, because I have a 62 and a 62, and a 70 and a 70, now, Courtney and Haley, you're absolutely right. And Liana, as you're rotating that, we would know angle B is how many degrees? 48. So two angles of EFG are congruent to two angles of ABC. So triangle EFG is similar, not congruent, just the squiggle, just the tilde. Now we got to make sure that we put the letters in the right order. EFG, what should replace E from the other triangle? A. F should be B, and G should be C. So something to remember, as Addison told us, all your angles add up to 180 degrees. So if you know two of them, we can figure out what that third one is mathematically. Okay? We are going to skip example number 2. You are welcome. We're going to go to the back. Okay, we have some more terminology here. Ms. Hoff will hopefully tell you how to spell it correctly. One type of indirect measure is shadow reckoning. Shadow reckoning. two objects and their shadows form two sides of right triangles. Since two pairs of corresponding angles are congruent, the two right triangles are similar. So today, the biggest frustration many of us are going to have is we look at this and I'm like, are there two triangles? Draw them separately. Okay, so this problem says in the figure, triangle DBA is similar to triangle ECA. Raymond wants to know the distance across the lake. Does everybody see when it talks DBA? DBA, that smaller triangle? So draw that right down here. DBA. What information from the diagram should I put in the triangle I just drew? 320 and the 40, the 90 in the corner, and then I don't know if you can see it, A has a little tick mark on it. Okay, there's one triangle. Now they say ECA, ECA. That's the big triangle. ECA. Now, what information should I transfer on this one? Tone? Still do the square down in E. I like it. Now be careful. Yeah, you saw that as soon as you did the double take. 320 was from A to B, and then they show you from B to C is 162. Well, we need all the way from A all the way to C, so we need to add those together. 482. And the last thing that I probably need in my diagram, ooh, tick marking, A. One more thing. What are we trying to even figure out? The distance across the lake, which they have as letter D. Remember in 7-4 when you had two shapes and you had to figure out the missing side and you had to set up the two numbers as a fraction equal to two numbers as a fraction? You're doing that again today. Who can set it up for me? What over what equals what over what? Got it, Tone? Thoughts? You don't like it? Why not? I don't like it either. And when they're in the same triangle, what do you know about them? They got to be in the same part of the fraction, right? Good observation. 482 and D. So if he puts 482 on top, what else does he have to put on top? The D. So D over 40. Okay? All right.
Well, that's a good question. You say, would it be the same thing? But when you cross multiply, it would be the same, right?
Your numbers would multiply against the wrong ones. All right, you guys know how to cross multiply. Do the butterfly now for me. And tell me how far it is across that lake. Correct, same exact size, same exact shape. Similar. They look the same, but they're probably bigger or smaller. Like they enlarged it or reduced it. Does that help you? Okay. Where is your work? I'm trying to steal a number from you and you didn't write it down. What is 482 times 40? Like that? Okay, thank you. Then, Bryce, when you divide by 32, you get 60.25, and we're going to put the meters on it. 60.25 meters. You might get decimals today. If you get a decimal that's really long and crazy and fills up your whole screen, you probably did something wrong. Okay, 60.25 is not so bad. 1 decimal point or 2, you're gonna be good. Is it 320? That is just my mistake. Thank you for asking. No, because I stole the numbers from Bryce. Okay. All right, example 4. Here's one that people get frustrated. I can't do this. There's no picture. Eduardo is 6 feet tall and casts a 12-foot shadow. You ready? Here's Miss Hoff's art skills. We've already heard her terrible choir skills this morning. So here's her art skills. There stands Eduardo. Okay? Eduardo is 6 feet tall. So from the top of his head down to the ground is 6 feet. Now, if you're standing outside and there's a shadow, where is the shadow? On the ground, right? So his shadow is here. And how long is his shadow? 12. Now, everybody see, technically, if I connected the top of his head to the top of the head of his shadow, we'd have a right triangle. Okay. Now we're going to have Diane. That's your grandma? Haley's grandma. Okay. How tall is Diane? We don't know. What do we want to call it? X. Okay. Thank you for reading that.
That means that she would have been 22.
Okay.
No.
How long is her shadow? 11. If I connect the top of her head to the top of the head of her shadow, I have a right triangle. Somebody who has not answered for me today, set up my proportion. What to what equals what to what? You have 2 triangles now. Haley.
12 over 11 equals 6 over x.
Thoughts? You already got the approval from Caitlin. You're good to go, she says. 12 and 6 are in the same triangle. Yeah, I like it. Nicely done. Cross multiply. See how tall Haley's grandma actually is. Well, this is going to say she's kind of short anyway, so. Is that what it's labeled? Meters? 66 divided by 12 is 5.5. What's my label? Feet. Diane's height. How tall is Diane? 5.5 feet. Okay?
Can we skip example 5 too? No.
Who's your favorite math teacher?
Miss Lucer.
Oh, no.
Get out.
It's hot.
Yes, we're going to skip example number 5. I'm going to give you your homework, and you're going to cross off number 1, and then you're going to do the rest of these problems, okay?
I know that extra.